Let's actually make a more complicated lake. Let's make, let's make a stomach. It's a stomach. Alright. So I'm kind of drawing these things just to, because I need to get my head around exactly all the cases, and I might think I have a good idea on something, but if I don't actually take the time and draw a few things out, I might miss something real obvious about how the water should move. Or have some edge case that like just won't work. So we're gonna need this to kind of go like this. And then I guess it's supposed to kind of go out. And this is supposed to come in. Let's add something over here. We had like a rock. So let's see. I mean, we don't really need depth here, I don't think. Are you adding turbulence as well? Well, I would think so. Basically, if you combined like the speed of the water with the depth, right? Because we already have the depth value at a current place, and if we had the speed of the water, we could always be like, well, if the speed is greater than a certain value or whatever, then this area should have turbulence, right? And then just kind of fade it in or what have you if the height works properly. Though that might be something to think about, right? Like, how would we, if we had turbulence, let's. Where would we have turbulence on this thing? Would we have turbulence like right here? Or would we have turbulence right here? And what would define that? I guess it would be the... Because it's obvious we have our input and our output spots here. So... I mean, we could have turbulence on the input spots and just like... But do we need, a turbulence map or something like that? Do we need another texture which actually pre-computes where turbulence is supposed to be? Because if we're in our pixel shader, we can't sample the values around us. So the question would be, how do we, if we could detect based on the height and speed that we should be a turbulent region, how would we have the turbulence nicely fade in? And the answer to that would be, well, we could have, a noise texture, something that pans across, and that would fade stuff in. But there would still be kind of a hard line of where turbulence starts. Is that what we want, though? Would that look bad? I'm trying to visualize that. I mean, we could also, if we pre-computed the turbulence, we could add it to the flow field. It'd be like RGB is XYZ for the direction of the water, and then the A value is the turbulence value, right? So it's not like we would need to sacrifice reading another texture sample or something. We could throw it in there with the amount of values that we have. So that's something we probably want to calculate a turbulence value. So if we're gonna make an algorithm for creating this flow field, how it works? Well, we'd want to have our starting positions and our ending positions, right? And what we could do is we could search from our starting positions to our ending positions. And like if your starting position had a weight, such as this, well, yeah, we'd want a weight for the input and a weight for the output. Does the weight for the output matter? Because we could discover the weight for the output based on just flow, right? Like, though of course that doesn't really make sense if we had, you know, like a small outlet here that went over to the right. Kind of like that. How much water is going to go out that direction? You know, you would want to... Yeah, so we want like an input weight and an output weight. Alright, so let's start writing down some notes for this. So we can have input weight for water, output weight for outflows, water sources, output weight for outflows. So how would it work? I guess we could say like starting here, we could do like an outward search. So if we like started searching for the outflows, we could like find like a kind of an overarching pattern, and it would look something like that. But I think we want that to be something that comes out of it, not something that is defined by it. So if we just searched out and basically the cost of the thing, like things that are closer to shore have a higher cost for our search algorithm. So if we just did it based on shore, what would happen is we'd be going along and we'd have like a strength of the flow or something like that. How would we define it though? So what we could do is, if we're searching outward, we have a cost, and the cost is going to decrease the magnitude of the flow, and the direction is going to be where we came from. So we would go in like kind of these values, because we'd be like far enough away from shore, we would just be going like straight towards it. And so what would end up happening is we'd have like a straight shot. But how do we know to like search this direction and that the water should be coming from that direction? Or should we, our heuristic should just go like straight down, and then like we should kind of go towards, like we should search towards the output. So like from this input, what you would do is you would search to this output, and then you would search to that output, and you'd get, you know, a like an A-star path that kind of looks like, you know, like this, and like that. So that would give us like the basic general idea, and then like, you know, we could blur it and it would look fine. But that would be like our basic, like boom, okay, we have generated the flow of the water, and then the rest of it should be like noise that we throw in here. Why don't I just look up like create flow field for lake? Let's see if we can come up with anything. I like how I looked this up and it's a whole bunch of like government lake flow field stuff. So is there some sort of discovery system that I can do? Like maybe, because I could do a search algorithm. The search algorithm can find the direction that things would go, but you know what we're not seeing is we're not seeing the spreading out of the water. So like if we did a second pass here, where like we know where the main flow is, and then like the second pass would basically search in all directions and have a fall off. So for every you know pixel here that is the main flow, it would go out in all directions, and the flow would decrease based on distance and on distance to shore, and then it would take like the maximum value. So like a flow here would get smaller and smaller and smaller and smaller until it's like 0. But the flow here would, you know, like as you could see, like what the flow would actually do here is, you know, like we would get flow that would go towards shore if we did that. So what we would want is, I mean, we could have a cost for the flow to be like, if we had the direction that the flow is supposed to go, which would be, you know, just this, we could take, you know, the general flow of the thing in that area and just be like, well, the flow is down, so what we would do is, you know, if we were searching this way, we'd actually be saying, well, the cost is pretty great because the cost is actually farther from where you would expect to be, which is here. So what would end up happening is like these diagonals would be valued, and we might actually see this flow field here, because this one would not go that far out because it's not supposed to. Like it'd be like, you're going too far. So we'd end up seeing is, we wouldn't see this turn though, which is kind of what we need to see. Is there some sort of discovery process that we could use instead? Like if we have the basic general flow, can we send out like, you know, can we light a room with you know, sound waves or whatever, right? So like if we just had, you know, like these circles come out And I don't know what the hell I'm doing, so, you know, if somebody has a better idea, feel free to chime in. So if we threw like, you know, if we did like a sonar ping or something, what would happen? As this thing comes out, you know, we would see this thing do this, and then it would bounce back over here on it. And we could get distances and stuff like that using that, but we already have the distance, so it doesn't really matter. Like if we sent out a little thing and we basically gave it like a random vector and we wanted it to more go towards the bottom, like in just if we sent out like a little pixel man and we're just like go to this outflow in a random direction, and it would just like stumble around, and like if it just randomly decided to, you know, if it had like a higher random weight to go towards this, you know, if it had a random weight, like so, like if you threw this guy out here, his path would go towards this thing, but it would have like a random waddle, so like at this point most likely he would be over here, but like he always has to choose a direction to go. He can't go back. Like if he couldn't go back, like if he had to stick over here, he would like he could randomly waddle all over the place. But you know, he's probably not going to random that much if he just went left or right or something. He might do something like that, and we would never have a situation where, I mean, this random waddle would come from this direction or from this direction. But this guy would always have to come towards here, because we could say like, well, you know, when you run into shore, you can't go too close to shore. And it'd be pretty effective at detecting, you know, and then we basically take these lines, we all average them together. So if we sent out like 1,000 of these little units and just like go to here, and it would, you know, randomly go towards it, we would see flow that would come out, and it would try to stick towards here, and it would discover these little islands. I know this picture just looks like trash right now. It's pretty funny. But we would never discover like a little inlet or something up top. Like if there was a little area there that we needed to have flow go around, we would never go there. And the question is that fine? You know, like if there was no input from this direction in a lake, what you would see is that that area would be very calm. So why don't we draw that in there? Can I make the little units bounce off of something? Yes, but it'd be easier to avoid them. Like if you're close to shore, you just add the distance from shore. Like if you're mathematically trying to decide where to go, you can basically say like, well, I can randomly go, you know, down, right, or left, and then you add like a % chance to choose those based on a weight. Like, well, it's 1,000 units from shore to the left, and you know, 500 to the right. So, and if I add the weights together, it's gonna avoid the left and prefer the right, so that the thing would, you know, mathematically there's a chance you would actually encounter the shore, in which case you just be like, well, I can't go there. So, you know, the math would just be, you know, 100% the other direction. So they would kind of end up bouncing just like that. So if we had this guy go, if he could only go towards this object, pretty much, like we locked an axis, like he can't go backwards. There's a chance that we would have some flow like that, but we would absolutely never have a flow that went up into an area like this. Just never. There would be, the flow field for that would have nothing in it. It would basically, you know, we could blur it and, you know, like the flow could, you know, kind of come out. So we'd have like, you know, some blurred edges or something, but an object that got up here would never leave. But we would see this sort of thing. And I don't like complicated solutions like this because, yeah. So the other solution would be, what if we just draw the flow field by hand? I mean, you know, I can look at a lake and see what it's supposed to do. I can look at a river and be like, yeah, it should do that. I'd rather not, though. I'm an engineer. I write programs that solve problems instead of solving them myself. Well, if we, instead of having some sort of algorithm where literally you could never go up, it was just like, the chances of you choosing to go up are very small, then it could happen. And if we had like some sort of winding river thing, we would have to have these things go up. So really, it's just like we have a high chance of going towards this line for flow, and we just have like a magnitude distance on there. So I think that might be okay for scattering out the flow field. I mean, we're not going for absolute perfection here. We're going for the good enough. Because if you wanted something that looked great and had all this crazy stuff, what you do is you just draw the damn thing on there yourself until it looked correct. But we don't have an army of developers. So I think having a search algorithm would be fine if we blurred out the search algorithm. Like we could do rubber banding on the search, so these things could turn into straight lines. I mean, the other thing we could do is we could try to make like a mathematical curve to it, but I'm not a fan of fancy math curves. Okay, so let's say we send out these little units. We basically have these little robots that we send out at the start here, and they try to go towards the end, and they just randomly kind of waddle around. How do we weight them? Could we just do every one of them as a weight of 1? And then we just like average everything together after we're finished? And how random do we make them? Like, if we made them choose a random pixel every single time, you know, they might do something crazy and we would end up with like an average flow of nothing. But if we had it so they like pick a direction and they went for quite a ways and then basically stopped and then picked another direction, and if they ran into something, they would stop moving. So like it ran into the shore, so it'd be like, okay, I need to go in another direction. And I mean, we could have them reflect based on the shore, something like that, or we could just say like it can pick another random direction. Well, that would be interesting if we like took this flow and instead of having like a whole bunch of crazy random waddle, like this will cast a ray out, you know, from every direction. So like it cast a ray out here until it ran into something. Like, could we do something like this? So this flow would like hit over here. So if we like cast a ray out here, it hits this shore, and then what we would do is maybe pick a random direction and like have it decrease over time. Well, to do a reflection, I need to get a normal for a shore, which would mean basically scanning the map and then actually creating it, because I don't have the geometry of the shore. I have, you know, I'd have to look for it, and then based on the shore pieces that are, you know, farthest out in a certain plane or whatever, then I'd have to average together all of it to create a shore normal. I'd rather not have to do that, you know, rather have it be so it could reflect off at weird ass angles. But if we did a reflection, and we like averaged them all together, right? Like, you know, say there's like a certain number of bounces that you would do. Like if you would bounce like once or twice, like, you know, bounce once, and then like you would end there, and then if you averaged them all together, you know, and like we could do it like a bounce here. And an average of all these would have like a straight over water flow. It's still not exactly what I want. Well, is there some other value that we could do? Like, we just write down our stuff. Alright, so step 1, do a star search from each inflow to each outflow. Step 2, question mark. Step 4 is blur the damn thing. Step 5 is create texture. So I mean, people have done, you know, their like PhDs and crap like this, so the problem is a lot of this is too complicated. Like, when you Google a bunch of stuff, you're like, you know, crap is too complicated for really what we need, so I need to pick out the basic ideas. So another question, you know, another thing I could do is, instead of trying to model this using just actors singularly, like I could have, you know, like if you had 1,000 bouncy balls and you poured them down the staircase, where are they gonna go? Well, if you poured one bouncy ball down the stairs, it would just bounce all the way down and be fine. But if you pour a whole bunch of them and they actually collide with each other, then they would actually, you know, make the flow. And if you had enough bouncy balls, you'd be able to do it. So if I had, you know, a whole bunch of bouncy balls that I could throw out here and move them around, what would that look like? You know, like a whole bunch of them, and you just put them on there, and then like they kind of bounce on shore, and you know, when they got here, they'd be able to spread out and do their thing, and you know, they get pushed around. And but the problem is, you know, bouncy balls here would actually like screw this up, and this stuff wouldn't flow worth shit because everything's clogging into this drain. So maybe there'd be some stuff that would get here, but then this is going to very quickly fill up unless the flow is good enough that, you know, things that get here just very quickly flow out. So bonk, 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 bonk. But I'd have to have like some sort of physics simulation for that, which would be like a whole thing to write. Hmm. Well, let's think. Let's think. If I had all these pixels and all these things that came out, and I could advance the entire thing one step at a time. So if for every pixel on these main paths I spawned one pixel out from them, you know, I spawned one thing like this. You know, like every tick of this simulation, I would spawn another pixel behind it, and then these things would like randomly move out. Maybe they could repel each other. And we would see like these things would tend to go towards the flow. Like we could just like look over, do like a collision sweep to our nearest, like where we were spawned from, and get our flow. Direction. So like this pixel would have like a flow direction of straight down, and same with this one, but they'd be spawned at the same time. So this guy would be like, okay, well I can't go down, so I'm gonna go right. And this guy would be like, I can't go down, so I'll go right. You know, all along this thing. And you know, this guy down here, the last pixel would be able to be like, I can go down, so he would go down. And so like this guy next frame, you'd be like, okay, I can go down, so he would go down and all that. So what would end up happening is, this pixel would be like, can I go up? He can't go up, he can't go anywhere unless this guy moves, so he would move out. And we could give him a number of steps to take. Like we could run the simulation for a number of steps, and we could save the movement in there. So what would that look like? We would have these dots, and they would eventually fill out over here because there's nothing there. These things wouldn't be able to move into the shore. These dots here would be clearing out, so these dots would be able to easily clear. They would basically be like, I'm trying to move in this direction, and all of them really would very quickly actually move in that direction. So, and then we'd have these dots would actually fill up over here. And the thing is, we have to keep spawning dots in order to do this. We have to keep spawning dots all along this frame, all along this line as we do this. And we could spawn dots on every single one of these lines. And what would happen, because obviously we have more, it would be the width of the thing. Like if this is all in pixel land, the flow that's going to come out from the lake is going to be limited to the width of it in pixels. So kind of a small channel here, like literally is not going to get much flow out of it just because it's not very big, even though like maybe it's super deep or something like that, and we should be able to clear out a lot of space quickly. So what would end up happening is this area would end up with a lot of movement into here and out like that because there's just not enough throughput. Can we solve that with a speed differential? Sort of like things that are closer go faster towards where they're supposed to go? Or can we solve it with some sort of smart updating things? It's like, if we updated this entire line, like everything along this channel would be able to shift down. Well, what if we had it so that if we were able to move far enough in the direction that we wanted to go, that's when the particle dies? So these particles that are actually getting moved down here would clear out faster because they've been able to move in the direction they want to go, versus these guys who are like forced to go all the way around or something would live longer because they weren't able to move as far as they wanted. So we get like this flow that would come into here. Would we want things to annihilate each other if they collided in weird ways? Can we have things push other things faster? Like I'm trying to go this direction, so you need to move more this tick. And you know, we could have objects move multiple spaces. You know, have it be a grid, but have it be so you can move and kind of, you know, ghost through stuff. As long as it wasn't sure, you could ghost through other particles. How would you know which way to go, though? You'd always go towards this thing? Some really weird behavior out of this. Well, let's think. Is this thing actually going to cause a backup? Because we're spawning all sorts of balls coming off of this thing, which are all going to try to go in this direction. But they're going to be forced out because we're going to update, I guess, top to bottom, so everything will go down. And if we went top to bottom, things would tend to go outwards, and then kind of things would move out and then down and out and down and out and down, out and down, and they'd all tend to pile up on top of each other. And then when it got in the middle here, it would have problems moving, so we'd have it build up. But the problem is we would end up with like stuff that would kind of come like this and then would meet over there. The question is that okay? Because there's no history there. And this is where like depth would come into play or something like that. This is pretty much, you know, the flow field is almost the most important part here, this algorithm. So I mean, we can take a while and think about this. This is not like, oh my god, I'm stuck, this is awful. It's like, no, like this is a cool problem to work on and to think about. You know, like we're basically trying to model a fluid and come up with a way to do that. And I've never done this before, so we're not expecting to come up with some crazy, you know, like, oh my god, there's just this one solution, you just implement this one thing and then it just works. We're trying to model a frickin' lake here with a damn rock in the middle, and we're trying to figure out simple rules which will actually model that. Like, that's not like a, you know, just give me 5 minutes and a pencil. You know, here's a lake algorithm in 2 seconds. And we're also trying to come up with a way that's not going to be like, you know, spend 3 months making some particle physics flow field simulation in order to do this. It's we're not trying to take all year to do this. We're trying to actually do it in, you know, a reasonable amount of time. So let's just read. This guy's got a blog post from 2013 on this. Let's see, what did this guy do? One of the most common methods of pathfinding is A-star. So this guy's got a vector field. Yeah, a flow field can be used to refer to as vector field, so calculating it. So we've got this cost field. But I mean, that's that's not what we're looking for. He's just spawning stuff there and seeing where it goes. Alright, so what is this? The algorithm starts by setting the event cell's value. The goal is to get its total cost set to 0 and gets... Yeah, so it's supposed to like find a goal path, and it would be like, search from, where we are to where we want to go, and, avoid the costs and all that stuff, and make a flow field that way. And we're not really trying to do that. We're trying to combine it together with other data. Yeah, fluid simulation is difficult, and we're trying to do it in like a couple lines of code and figure out a way to, fake it without doing something insane. This is where you need to like sit on a mountaintop and meditate for 3 weeks and then come down from the mountain and be like, I have seen the flow in my dreams. I just need to smoke up a whole bunch of dope and then I'll be able to do it. And then nothing happens. Alright, so basically what we want to do is we want this to be the average path. So we'll kind of start from this. So how would we implement something like that? It has to go out from this basic thing. We have to, like, these two forces here have to kind of equal each other out, and, when they combine, this value has to, this thing has to drain is basically what's happening, is this has to be successful in draining, and this needs to not be successful in draining. So like, if all these speeds were super fast, so these things went down, and what we need to do is we need to have this value here, this stuff, repel and push stuff away. But it's also that these areas need to repel, and these areas would repel, but we need, the water to come down real quick. So one thing we could do is have, like, we basically need if we had the life of the particle that we actually put out be extended by being farther away from this thing, but also get... I don't know, hell, the random search vector crap was actually, I think, doing a better job of some of this. Of discovering it, because these random vectors, given heuristics, would, these things would tend to avoid this area. And the randomness here would account for the physics. I mean, if we had a whole bunch of random crap go out at the same time and they could collide with each other, then we get this problem of getting, we need to drain, we need to get these guys the hell out of here. And unless we knew that this was, you know, an outflow, you know, how are we supposed to know that the speed of the water is so high here? Well, I mean, if we had the speed of the water is based on how far away it is, so like the water goes slower as it goes farther away. Well, let's think about it. If we spawn these objects out here and they decrease in speed when they can move, and when they can't move, they keep the same speed. So these things would tend to drain faster because they can't move. And these guys would tend to live longer. I mean, these guys would tend to go slower. So these guys would drain out super fast, and these guys would just, they would start piling up over here. You know, we'd see these things pile up. If we like ticked this simulation with all these things, these guys would pile up. And then they go super slow, and then we'd want them to die at some point. Like if they can't move at all, the particle dies. Or something like that. It's got only a certain number of iterations, so like the pixels that made it all the way around here, after a couple iterations, they would just disappear from existence. So if they can't move, they would not move. Alright. I mean, that's interesting. So, I mean, what would end up happening is, you know, things would actually move off into here, but then it would get squashed and nothing would happen. And it would actually create the flow that we'd need. It solves the problem of things moving out, because if they can't move, they'll die. So we're gonna. So what are our rules? Move. Spawn at a certain speed. If you cannot move for X frames, die. If you can move in a direction, slow down to a minimum speed. And each tick spawn a new particle in both directions on the main line. So what direction are we supposed to actually go for these particles? So like, if we did a search from like this location to this location, we would know we'd want to go like left and all that. These things are going to flow down. I mean, we could check like our collision and go right, and then if we can, we'd want to go in the direction of the value. So what we want, like pre-computed pathfinding. But I mean, we can throw another wrench in here for ourselves and just be like, you know, there's another outflow to this lake over here, you know. Yeah, how the hell do we deal with that? Because if we did pre-compute, if we did compute, you know, like a pathfinding element there, this guy would want to, oh, I can go this way, and would. But we'd have to, I guess we'd always want to move towards the direction, so instead of pre-computing a pathfinding thing, like a dot here wants to go to there, and it will just do that. Like it's always like wanting to go that direction. So it's going to get pulled around here, and once it got here, then it's just going to do that. So we're going to move toward the outflow position. So it's going to check collision with other particles on the map. And if you cannot move where you want, then try based on x/y coordinate. So it'll try to, you know, move down or left or something like that based on it. I mean, we could also have it use its historical vector to be like, well, you've been moving from left to right, so continue to move from left to right. So we could keep a momentum. Keep a momentum. Try to continue in the direction you've been going. And you have to move in some direction. If you cannot move, always try to move in a direction. So try, yeah. So move, you know, quote unquote backwards, even if possible. Alright, so what are we going to do then for, you know, completing this thing? So like if we do this simulation and we do